Hello, conference attendees. Thank you for virtually attending my talk today. Unfortunately, I cannot see you as this is pre-recorded, but trust me, I am still imagining all of you in your underwear to alleviate my presentation anxiety. To be honest, I think this speech coach suggestion is making me more anxious, so instead, I'm imagining all of you in your Sunday best, absolutely enthralled in my talk. My talk will introduce you to the Georgia Tech Web-Based Information Sharing Environment, GTYs. I will first motivate why we even need a system like GTYs, then I will give you a brief overview of the system. Finally, I will show you a real-world application of the environment as it applies to a study our group conducted at Lake Lanier, here in the state of Georgia. By the way, I'm Margot Paez, a PhD candidate at the Georgia Water Resources Institute. I'm sure you've experienced this scenario before. You've collected many data or samples, but don't have a good system for keeping track of what you have. Eventually, you find you're doing a cumbersome approach involving a label maker and lots of cabinet space. Maybe an old lab notebook to keep track of everything cryptically written in shorthand that only you understand. Maybe you have endless Excel spreadsheets stored across multiple folders and drives. After all, data storage is always changing, and who knows if anyone still knows what a floppy disk is, right? It's easy to become overwhelmed like our fearless Captain Kirk and his crew here. Surely it's not exactly like an infestation of tribbles, but who can tell one tribble from another, let alone share the intricate details of Sammy the Tribble's life on the Starship Enterprise when they're illogically stuffed into the nooks and crannies of the ship? Well, that's the kind of problem we face when it comes to the scale of data collection we do in the 21st century. We have the ability to collect and analyze megabytes to petabytes of data from an endless array of sensors and doohickeys that managing and sharing data on that scale becomes intractable with older by-hand approaches. In order to solve this problem, we need a full-service system that can provide robust user management, data management, as well as visualization and analysis tools. Not only this, but the system must be able to survive advances in data storage and computer operating system. It must have built-in scalability as data proliferation outgrows existing technology. The Georgia Tech web-based information sharing environment was built to solve many issues related to data collection, management, visualization, analysis, and sharing. The environment provides a broad range of capabilities from granular user management to data analysis. Additionally, GTYs makes it easy to store related information such as documents, images, and videos that are related to the data stored in the database and cloud storage. Of course, with GIS data, map visualization is essential, and GTYs provides capabilities for mapping data and easy access to related data items. You may be wondering why we chose to make GTYs a web application and not an operating system-based software. The simple answer is that the web browser is now the main way that we interact with data of all kinds. The web pages of the 90s are but a page in the history of the internet. We no longer surf the web to visit a website. We interact on web platforms and apps. Web apps are becoming so advanced that they really behave now like software within the browser. The benefit of this approach is that operating system compatibility is no longer an issue. GTYs can be accessible from any desktop or laptop. It can even be tailored for small devices like phones. Now, I will spend my remaining time sharing with you a real-world application of GTYs. First, let me explain that this system has been in development for a long time, and our group, GWRI, invested many funds over the years to make this a reality. So as we look at it as it applies to the Lake Lanier study, we should keep in mind that GTYs is not specific to this project alone, but a versatile and generalized system that has capabilities across many applications. This particular study is known as the Septic System Impact Study, and Gwinnett County is a major sponsor of this project. GWRI worked alongside the county as well as the University of Georgia, Cornell University, and USGS to make this study possible. As the slide clearly states, GWRI led the study to understand how the septic system surrounding Lake Lanier affect, if at all, the water quality of the lake. We wanted to understand the concentration and movement of septic effluent constituents in the groundwater and soils at these sites. It was also important for us to monitor the lake water quality near the septic sites and to also be able to assess the impact of the septic systems and then make recommendations to mitigate the effects based on our findings. There are many data-related issues that come up in the septic system impact study, and I will touch on 5 of such challenges. These challenges, though, all stem from the all-encompassing challenge of how do we support Gwinnett's data management needs beyond the life of the impact study. The first challenge is user management. There are multiple users who would like access to the data from the study, and these users come from different organizations. Not everyone who wants access should be granted the ability to edit or delete the data, for example. Some of the information stored may be only for the members of a specific organization and not another. For example, maybe the users from Cornell may want to make some of the data, but not all of it, accessible to the users from the University of Georgia. This requires granular user management. GTWise provides exactly that kind of granular user management support. Administrators from the governing organization can add users to the system using a very easy-to-use form. The new user will get an email asking them to create a new password. This, though, does not grant them access to any data until the administrator makes that possible. For example, if you only want the user named Bob to have access to the Septic System Impact Study project, but not a project that is unrelated to the study, you only need to grant Bob permission on the septic study. Users have different permissions, such as being able to view content versus editing content or being an administrator. A user could grant access to view layers, but not add new ones or edit existing ones. You can even hide certain objects from the user. Well, there are not just measurements that need to be collected and stored. There are also documents that are related to those measurements that must be stored. Maybe photos of some of the Lake Cove sites were made. We'd want to store those somewhere, right? Well, with the document manager, that is easy. It functions very much like the File Explorer on your Windows operating system. There is a simple folder structure where you can add files or folders to an existing folder ad infinitum. The document manager is available at different points within GTWise at the project, layer, and feature levels. All files stored in the document manager can be downloaded as easily as they were uploaded. Any document can be stored in the document manager, but only documents that fall into the web-friendly category can be previewed in the browser. That includes PDFs, most images, videos, and audio. Spreadsheets cannot be viewed in the browser, so they are not supported in the preview, but they can be saved in the document manager. The impact study has a number of data-related challenges. Data comes from multiple sources, multiple groups, and are stored in multiple ways. Without a central and universal storage solution, it would be difficult to keep track and maintain a collection like this. The study, for example, requires periodic measurements of dozens of variables. Analysis across space and time is a clear requirement as a result. Data is collected at different locations in the lake too, so being able to quickly locate data based on lake location would also be necessary. GTWise provides support for data collection through the fully customizable variable and units modules. With these two modules, you can fully support all types of units and variables that your project needs. In the case of the Lanier study, we have many water quality specific variables that we added to the system. These variables are accessible across GTWise and are used in data visualization and analysis. This brings us to data visualization. For the septic system impact study, measurements were not only spatial, but also measured over time. Also, because these measurements were made at different locations on and around the lake, not just at varying depths below the water surface, the user needs to be able to find where the measurements were made on the lake. So that is a geospatial component to data visualization. The mapping module makes it easy to visualize the geospatial data that is stored in GTYs. It also makes it easy to navigate to stored data items on the fly. The data items themselves can be easily visualized as well, but we will examine that in the next challenge. Features can be grouped from the interactive map, and analyses of data items across features can also be generated from the map. All layers have styling options that can be customized and are unique to the user, so that each user can style their geospatial data to their liking. Aside from vector layers, raster or TIFF layers can also be displayed on the map. Statistics are generated for all rasters that are stored in GTYs, and the statistics can be used to create color maps based on the values stored in the layer. The environment also has a raster template module where style templates can be created and applied across all stored raster layers. Storing the data is one thing, but how can management professionals make decisions without analysis tools? With the impact study, it was important for us to be able to compare across both space and time. Given the thousands and thousands of collections made, finding relevant information and data would be impossible without being able to search through everything stored in GTYs. Lastly, a professional using GTYs may want to group certain features together for easy analysis later on. We have a tool called Views that allows users to bring in data items across the entire project and compare them on a single plot. It is easy to share the plotted results as well. They can be downloaded in a number of graphic formats and can also be printed directly from GTYs. Also, the individual data items can be viewed on their own, and the data stored for each of those data items can be downloaded from the data item page. Here's an example of time series data collected at a station near Beaufort Dam at Lake Lanier. The analysis module makes it possible to compare multiple time series of different variables and at different points in time on the same plot. The plotting tool makes it easy to zoom in and to examine specific features. The search module follows an and/or approach where basic search conditions can be used as building blocks that are combined to create more complicated and refined searches, which lead to more refined results. The result table returns layers, features, and data items. GTYs also have options for returning the complement of the results, that is, everything that is outside of the search conditions. Finally, search conditions can be related to the layer type, data type, such as XY or time series, as well as thresholds, variables, and data ranges. Finally, feature groups can be created and viewed either from the tabular side of GTYs or from the map. The search results are automatically grouped into a feature group that can be displayed on the map. The pink dots represent members of a feature group. In this case, these were from a search result. GTYs provides a wide range of support for the management professional. The Septic System Impact Study highlights the main features of GTYs, including its ability to solve issues of data management and sharing. Also, as stated at the beginning of my talk, GTYs is portable because it is accessible from any device with a web browser. The environment can host a variety of types of data, from vector layers to PDFs. It has analysis tools built in so that the user can go beyond data storage. Finally, GTYs is designed to support many data management applications, particularly in regard to environmental, water resources, and energy management. Thank you everyone for staying with me until the end of my talk. I would like to acknowledge the Gwinnett County Department of Water Resources and the Georgia Water Resources Institute for supporting this work. Finally, I would like to remember Dr. Martin Kistenmacher. Martin and I worked together on GTYs for nearly 2 years. We were a great team, and I feel a little bit like one of those 1970s cop TV shows where the cop loses his partner and can never bring himself to find another. Martin, I love you and I miss you. I still can't believe you're gone. But I finished the system for you, even though I know you wanted to finish it yourself. Thank you, everyone. And if you have questions, hopefully there will be time for me to answer them.